Okay, let's try the next question. Question number 2. It's an applied trigonometry question for the workshop we're doing on March 12th. And let's just try this question. Now, they tell us that there's this balloon up here. They give us that the distance down here, A to B, is 200 meters. They give us that one angle here, CAB, is 64 degrees. They tell us that this is 64 degrees, and that they tell us that it's 48 degrees on either side, I think, 48 degrees. They say that they both observe an angle of elevation of 48 degrees. So it's 48 degrees here, that's angle CBD, and 48 degrees here, angle CAD, 48 degrees on both sides, here and here. Okay, let's just start off here. First thing we can say is, do you know that AC has to be exactly the same length as AB? BC, rather. These two lines have to be, now why is that? Well, they both have 48 degrees going to the same height here. That's the opposite side. So the opposite over the hypotenuse is the sine of this 48 degrees on both sides. Well, they both have an opposite side of CD. The only way this could be the sine of 48, both be the sine of 48 degrees, is if AC and BC also equal each other. Otherwise, the fractions wouldn't be the same. Therefore, if they have the same sine ratio, the only way that could work is if the two hypotenuses were the same. Well, we know that these two sides are the same. We know one of them is 64 degrees. So the other one's 64 degrees because equal angles are opposite equal sides. So they both have to be 64. Now, this is in this triangle here, CAB, it adds up to 180 degrees. So just add 64 and 64, subtract it from 180, and you'll get 52 degrees. So now we know this angle up here is 52 degrees. And we know that because the angles in a triangle ACB add up to 180 degrees. Okay, let's try this. Let's say AC and BC equal x. We don't know what they are, but it's the same length. If we use the cos rule now, if we square these two sides, x squared plus x squared, minus 2 times x times the cosine of the angle in between them, it should equal this side, AB squared. That's what the cos rule is. You square the two sides on either side of the angle, minus 2 times then multiplied together times the cosine of the angle in between them. That's the cos rule. Well, this is kind of interesting. Let's take a look at this. We've got x squared plus x squared is 2x squared. And we can factor it out and get 1 minus the cos of 52 degrees. Hey, that's just a number. If we divide both sides by 2, 1 minus cos squared, we'll get x squared by itself. So x squared equals 200 squared divided by 2 times 1 minus the cos of 52 degrees. Well, there we go. Just take this, you get a number here, and you take the square root, and you get your answer of 228.12 meters. Well, that was the first question, is to find, I think, the length. Calculate the length. Oh, we've got the length of this side here now. We've got what this is. It's 228. It's 228 meters. So we've got that x side. But hey, maybe we can get at. We could. It might even be better. You could use the sine rule in this triangle too. There's another way of doing it. X goes with 64 the way 200 goes with the sine of 52. Hey, that's a much easier way. Multiply by the sine of 64, we get the same answer. Now we know the sine of 48 degrees is this height that they're asking for over this side of 28.12 meters. Well, all we do is multiply the sine of 48 times 228.12, and we get CD, the height the balloon is above. So the answer for the height is 169.52 meters. Hey, I showed you by the cos rule, but it's way better to use the sine rule. It's much easier. We would have been better. The sine rule is usually, if you can, an easier one to work with. Sometimes you can. But there it is, question 2. I hope that helps. I hope it is. I hope it does.